Code YouTube channel. Today we'll be solving LeetCode 633, sum of square numbers. Let's read the question first and understand it. Given a non-negative integer c, decide whether there are two integers a and b such that a square plus b square equal to c. Let's take this as an example. It's given 5 and we have to find a and b such that a square plus b square equal to 5, and there exist those numbers where a is 1 and b is 2. Okay, and if you square a and square b and sum those up, you'll get 5, which is the desired answer. Let's think about how we can solve this. Okay, a square plus b square is c. Okay, so one thing that is coming in my mind is really a brute force way of solving this. Brute force. Okay, let's see how we can solve that. We will go from 0 to the square root of c and y square root of c. So let's take example of 5. Why we should go up until square root of c? Because if we go beyond or one number higher than the square root of c, then we will exceed this target. For example, the square root of 5 is 2.23 something, right? And you might wonder how I got this 2.23. I just pre-calculated it, so I have that in mind. So if we go up until 3, then the square of 3 is 3 into 3 is 9, which is bigger than this number. So we just have to go up until the square root of this number. Okay, so basically if we go up until 2 squared is 4, which is less than this number target. So that's why we have to do square root of c. I hope that is clear now. All right, let's see. So we go b 0 to the square root of c. Okay, so what we have to do here is, if this equation is true, then we just return true, otherwise we return false. Okay, and let's think about the time complexity and space complexity of this solution. The time complexity is we are iterating from 0 to square root of c, 0 to square root of c. That means it's order of the square root of c, which basically boils down to the order of c. Okay, in the space complexity we are not using any extra space here, it's just order of 1. Okay, all right, so is there a better way we can do, or is there a way we can optimize this solution? Yes, definitely there is a way we can optimize this solution. Let's take this equation again. So a square plus b square is c, and what happens if we do a square is equal to c minus b square, right? And what is a here? A is basically square root of c minus b square, right? Okay, so now what we can do is we can basically iterate one of the number and find another number or calculate another number inside that loop, and then see if that particular number is equal to is actually the square root. So basically let's write this and then it will be more clear. Okay, so what if we do a, it goes from 0 up until 0 to the square root of that, okay, C, and we calculate B here. What is B? B is square root of C minus A square. I'm just doing B square equal to C minus A square, just interchanging these, okay? Hope it is not confusing here. All right, so now we can check, like, if B is equal to, basically, if B is equal to integer of B, if that is the case, we just return true, okay? Otherwise, we return false. What we are checking here is basically if this B is actually the perfect square root number, okay? So we're just checking if this doesn't have any decimal points. If it has decimal point, it will not be a perfect square. That's why we are doing this, okay? And let's talk about the space and time complexity for this solution. The time complexity for this solution is order of, again, the square root of C, which boils down to the time complexity of C, okay? And then space complexity, it is order of 1, as we are not allocating any space, okay? But let's think about the time complexity again. We are doing square root of this number. I think this also takes some additional time complexity here. So I think the square root of some particular number is log of n, okay? Log of n is basically C square minus that. That means let's put this as order of n. So this will basically boils down to log of order of n, okay? Let's code this up, and if we find a better approach or optimized approach better than this, we'll solve that as well. Let's code this up first. Okay, so as you can see, what we did was, for A in range, integer square root of C plus 1, okay? And we calculated B. What was B? So B, it was basically this one, C minus A square, right? C minus A times A, okay? And we calculated the square root of this. And what we checked was if B is equal to integer of B. What we're doing here is checking if this B is a perfect square root or not, okay? If this is the case, we just return true. If it is not the case, we just return false, okay? Okay, all right. I think that should be pretty much it. Let's run this code. Hopefully I'm not messing up something here. Let's run this. As you can see, it passes these test cases, and let's submit this. As you can see, this is pretty efficient. And let's see if we can optimize the time complexity for this solution. Let's go here. So another approach that I can think of is there a way we can boil this down or trickle this down to some problem? Let's see if there is a way. What if, let's take example of C equal to 5. If we can pre-compute these squares of the numbers up until the square root of C. The square root of C was 2.23, and the floor of this number is 2. We'll pre-compute the square root or squares of the numbers up until the square root of this. So 0, 1, and 1 into 1 is 1, and 2 into 2 is 4. Okay, we have this as numbers, okay? And then we'll have left pointer and we'll have right pointer, and left pointer points to the left most element, and right pointer points to the rightmost element, right? Now we'll check like if left is less than right. We'll check in while we have that. We will check if the sum or nums left sum is nums left plus nums right, okay? And then if the sum is the target, basically this is the target now, okay? We are basically, so see here, this is basically boils down to a square plus b square, right? Because we are squaring the numbers and we are checking if there exist two numbers such that the sum is equal to this target. I hope that makes sense, okay? Now if the sum is equal to the number or the target, we just return true, okay? And if that is not the case, if the sum is greater than C, the target, we have to shift the right pointer, right? And if that is not the case, we'll just return, or we'll shift the left pointer, and if we didn't find anything, we'll just return false, okay? I hope that is clear. So basically what we did is we find the squares of every numbers here up until the square root of the target, and then we did the two-sum problem, like solve this using two-sum problem, where we check if the sum of the left and right numbers is equal to C, we just return true. If that is greater, we just shift the right pointer. If it is less, we shift the left pointer so that it can be balanced, and then we just return false if we cannot find anything. Let's talk about the space and time complexity for this solution. The time complexity for this solution is we are going from left to right. Basically, in the very worst case, it will go through all the elements, so that will be square root of C. It boils down to the order of C, right? And if we talk about the space complexity, we are storing the numbers up until the square root of C, so it is also like square root of C, and then boils down to square root of or order of C, okay? That is the two-sum approach, and let's code this up. I hope this is clear now. The code is pretty much simple, okay? Let's clear this code, and then, as we said, first we have to calculate these numbers, pre-compute these numbers. So numbers is I cross I for I in range, integer square root of C plus 1 if we, because we have to go up until that number, and Python is non-inclusive. And now, as we said, we'll have left pointer, we'll have right pointer pointed to the length of nums minus 1, and while left is less than or equal to right, or it is, we calculated the sum, num sum, or sqr sum is nums of left plus nums of right, okay? And then now what we did was, if square sum was actually C, return true, okay? And then if square sum is greater than our target, which is C, we just shift our right pointer, okay? else we just shift our left pointer. Okay, and then at last we just return false because we didn't find anything. Okay, I think that should be pretty much it. Let's run the code. As you can see, pass these test cases and let's submit this. As you can see, it is a little bit more efficient than the solution that we did earlier, and that is pretty much it. If you find this helpful, just hit like, hit subscribe, and I'll bring more of this type of videos in future, and I hope to meet you soon. Thank you for watching this.